Three-letter words are formed using the letters A, B, C, D, E, F, G. How many such words are possible for each of the following conditions? All right, so for all of these parts, we are going to consider that we can always assume that order matters since they are words that we're forming. And that should be true for all of the parts, but part A says no condition is imposed, meaning no additional condition is imposed. But for all of these, we can assume that order does not matter, and that's important because we always want to consider the possibility of using the combinations formula since that's the only one in which order does not matter. So it can be convenient if the problem has a situation where order doesn't matter, then you know to use the combinations formula. And if it isn't a situation like that, if it is one where order does matter, then you're definitely not going to be using the combinations formula. So all of these are permutations, and we're going to use the fundamental counting rule to figure these out. The fundamental counting rule says that for however many selections you have, and in each case we are going to select 3 letters, each time we make a choice, there's going to be a certain number of possibilities for each choice. And when we multiply all those together, we'll get the answer of how many possible combinations, or I should say permutations, there are for that case. So for part A, we just want to select 3 letters to form a word where order matters, but we are allowed to use repetition because it says no condition is imposed beyond the fact that order matters. So for instance, if I wanted to form the word dad, I would be using the D more than once. So that means that for every selection, I am allowed to choose from 7 possible letters. And so when I multiply all those together, 7 to the power of 3, I get my answer of 343. For part B, we're going to be adding the condition that no letter can be repeated in a word. So for part B, I could not make the word dad. Maybe I should make a word like dab, for instance. So that means that for the first choice, I have 7 letters to pick from, and then I can never use that D again. So then the next time I make a pick, I only have 6 letters left to choose from, and then 5. So that would be 7 times 6 times 5. And this could also be accomplished by using the permutations formula Npr, because the permutations formula Npr accomplishes exactly this. It does it by, I'll write it off to the side here. Okay, the permutations formula Npr is n factorial over n minus r factorial. And the requirement is that repetitions are not allowed, or in other words, you're doing selections without replacement. And so for part B, the NPR formula fits the bill. So here N would be the 7 letters we have to choose from, and R would be the 3 spaces we're going to fill. So we would be doing 7 factorial over 7 minus 3, which is 4 factorial. And mathematically, if I expand this, 7 times 6 times 5 times 4 times 3 times 2 times 1, and then I expand the bottom as well, then I get a lot canceling off, right? All these cancel each other to 1. So notice that I get the same result as I got by using the fundamental counting rule. Another way of calculating this very cleverly, especially useful when you're doing big numbers, is instead of expanding the top all the way down to 1 and expanding the bottom all the way down to 1, I could have chosen to leave the bottom as a chunk of 4 factorial and then expand the top only as far as 4 factorial, because then this piece and this piece cancel to 1. Very efficient. And then lastly, Excel has a permutations formula. So I can type in permute, okay? You can see the choice that's coming up here, permute. And I'm going to put in the number that I have to choose from, comma, the number of selections I'm going to make, and I get that same answer. For part C, it says each word must begin with the letter A. Okay, so we're starting back as if we just read the beginning part, that 3-letter words are formed using these 7 letters, and how many can I do? So the only condition we're adding to that initial introduction is that each word must begin with the letter A. So what has that done for us? Well, it means that the first letter is already assigned and you don't have a choice other than the 1. Then you have 2 more spaces that you can pick anything you want. So you can have 7 choices for each. So the answer will be 7 squared or 49. Okay, so far we have 343 for part A, 210 for part B, and 49 for part C. Part D says the letter C must be at the end. Well, that's the same kind of scenario, just a little different, but it comes out mathematically the same because the last letter is predetermined. We only have 1 choice, and we still have 7 choices for the other 2. So it's still going to be 49. And finally, part E says the second letter must be a vowel. Well, how many vowels do we have here? We have A and E. So there's only 2 choices for that middle letter. The other 2, we have 7 options each. So 7 times 7 is 49. 49 times 2 is 98. And that's the answer for the last part.